Students, in this video I'm going to discuss few examples and then definition of limit at infinity and infinite limits. So first we are taking some examples based on the limit. So do the following limits exist? If yes, then find them. So we have taken 5 examples here. First example is limit x tending to a sine 1 upon x minus 1. Second example is limit x tending to 0 e raised to the power 1 by x divided by e raised to the power 1 by x plus 1. Third example is limit x tending to 1 upon 2 raised to the power x minus 1. Fourth example is limit x tending to 1 f of x, where f of x is given by this. F of x is 3x minus 2 when x is less than 1 and 4x square minus 3x when x is greater than 1. Fifth limit is limit x tending to 0 magnitude of x divided by x. So we will discuss one by one. So first one, limit x tending to a sine 1 over x minus 1. So to find out the limit, basically we will use one-sided limits. That means left hand side limit and the right hand side limits. Find out the limits. If both limit exists and they are equal, then we can say that limit exists. Otherwise limit does not exist. Fine. So first we are finding the left hand side limit. So what is the definition? Definition says that according to this problem, left hand side limit will be limit x tending to this 1 minus 0 sine 1 over x minus 1, this function. So in place of 1 we are having 1 minus 0. This is the left hand side limit. Now we will convert this problem from x to h, a new variable. So for this we need a transformation, which is this. X is equal to, based on this, just replace the 0 by h. So 1 minus h. X is equals to 1 minus h. So in place of 1 minus 0, just replace this 0 by h. So 1 minus h. So just replace this x equal to 1 minus h here. So we get sine 1 upon x is replaced by 1 minus h minus 1. And here now x, when x is tending to 1, obviously h tending to 0. So that's why h tending to 0. Fine. So now problem is in terms of h rather than x. So limit h tending to 0. Simplify this, 1 is cancelled out with this, minus 1 by h. And now sine is an odd function, so that's why minus sine 1 upon h. But as h tending to 0, this is actually a finite value, but oscillatory in nature, because sine always laying in between minus 1 and 1. So this is a finite value laying in between minus 1 and 1, and we are having no definite value. What will be the definite value of this when h tending to 0? So that's why limit does not exist here. Similarly, right hand side limit. When you find out the right hand side limit, then again you will face the same problem. That's why limit does not exist in this case. Now the second one, left hand side limit. Second problem, this. So left hand side limit is limit x tending to point is 0. So 0 minus 0 will be the left hand side limit. So 0 minus 0 e raised to the power 1 by x, e raised to the power 1 by x plus 1. And now use this transformation. The second 0, 0 minus 0, the second 0 is replaced by h. So 0 minus h, just like in previous case. Fine. So now x is equal to minus h. So now the limit will be limit h tending to 0 e raised to the power minus 1 by h divided by e raised to the power minus h plus 1. Put the values, h tending to 0 here. So this will be e raised to the power minus infinite, that means 0. So 0 upon 0 plus 1, that means 0. Because e raised to the power minus infinite is 1 by e raised to the power infinite, 1 by infinite, and so 0. Now the right hand side limit. A right hand side limit is limit x tending to now 0 plus 0. Here is 0 minus 0 left hand side. Here is 0 plus 0 right hand side limit. E raised to the power 1 by x divided by e raised to the power 1 by x plus 1. Now transformation will be x equal to 0 plus second 0 is replaced by h. So 0 plus h. Here is 0 minus h. Here is 0 plus h. Fine. So this. And then replace this x equal to h here. So limit h tending to 0 e raised to the power 1 by h divided by e raised to the power 1 by h plus 1. Now divide this numerator and denominator by e raised to the power 1 by h. So what you will get here, you will get 1 plus e raised to the power minus 1 by h. Put the limit, so this will be 0. So 1 upon 1 plus 0 is equal to 1. So here the left hand side limit is 0, here the right hand side limit is 1. Both exist, but they are unequal. That's why left hand side limit is not equal to right hand side limit, and that's why limit does not exist. Fine. So similarly, other examples. Third example, limit HLL function, limit x tending to 1 minus 0 f of x. What is f of x here? F of x is 1 upon 2 raised to the power x minus 1. Fine. 1 over 2 raised to the power x minus 1. So now x, here left hand side limit 1 minus 0. So x is replaced by 1 minus h, just like in previous case. So limit x tending to 1 minus 0, function is 1 upon 2 raised to the power x minus 1. So this is equals to this. So limit h tending to 0, 2 raised to the power minus 1 upon minus h. Put x equal to 1 minus h here. So minus h. When you put h tending to 0, what you will get? 2 raised to the power minus 1 by h here. Put h tending to 0, this will be minus infinite, so 0, and so value will be 0. Finally, because this will be 2 raised to the power minus infinite. That means 1 upon 2 raised to the power infinite. So 1 by infinite, so 0. Right hand side limit x tending to 1 plus 0, f of x. F of x is 1 upon 2 raised to the power 1 upon x minus 1. So here x is 1 plus 0, just like here 1 minus 0, here is 1 plus 0, and this second 0 is replaced by h. Fine. So x transformation will be x equal to 1 plus h. Substitute the values. Finally you will see that the limit will be infinite. So here is 0, here is infinite. So this limit does not exist.